Hi guys, this is lesson 2-6, represent polygons on the coordinate plane. In this lesson, you will find side lengths of polygons on a coordinate plane. You will also find the perimeter of polygons on the coordinate plane. Let's look at solve and discuss a question. Draw a polygon with vertices at A, -1, 6, B, -7, 6, C, -7, -3, and D, -1, -3. Then find the perimeter of the polygon. Okay, so first step, what do you need to do? You need to plot the points. Let's plot the points on the coordinate grid provided below. -1 is your x value. So you need to go horizontally to the left. -1 is right here. +6, that is your y value. Go up 6. Go left 1, go up 6. That is your point. Point A. Point B, in the same way, -7 on the x-axis. Go up 6. That is B. Point C, -7, -3. Go down 3 from -7. C. And then D, -1, -3. And so if you connect all the dots, what do you see? A rectangle. Now you're going to find the perimeter of this polygon. What is the distance between the points? What's the distance between A and B? You can count or you can subtract their x values, right? Because it's a horizontal distance. A is -1, 6, B is -7, 6. So their horizontal distance, they're on the same quadrant. So absolute value 7 and absolute value 1, are they subtracted or added? They are subtracted because they're on the same quadrant, just like we learned last lesson. So 7 minus 1 is 6. That is your 6. Distance 6 units. Or you can count 1, 2, 3, 4, 5, 6 and check your answer. Yes, it is correct. Okay. What about the vertical distance? You can find the vertical distance between point A and D. D is -1, -3. You have the same x values. You need to find the vertical distance by subtracting your y values. 6 or subtracting or adding, right? They're in different quadrants. So in this case, you're going to add the absolute values of these y values. So 6 plus 3 will be 9. And you can check by counting 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Good. So we have 6 units by 9 units. You have 2 6-unit sides and 2 9-unit sides. So your perimeter should be 6 plus 6 plus 9 plus 9 units, which is 30 units. Okay, so the perimeter would be 30 units. Let's look at focus on math practices. What type of polygon did you draw? A rectangle. Use the definition to justify your answer. What is the definition of a rectangle? Okay, the opposite sides are equal length, and also all 4 angles are right angles for a rectangle. Those are the properties of rectangle, and those are the definition of the rectangle. Let's write that down. Okay. The rectangle, and by definition, the rectangle has the opposite sides are equal in length, and all 4 angles should be right angles. Let's look at essential question. You're going to think about this question throughout the lesson. How is distance used to solve problems about polygons in a coordinate plane? Let's look at example 1. Find the perimeter of a rectangle. An archaeologist used a coordinate plane to map a dig site. She marked the corners of a building with flags as shown. How much rope does she need to go around the building, right? So we got 4 A, B, C, Ds, and then we got working tent, food tent, right? You need to go around the building, which means you're not going to include the working tent, food tent. It's just the location of the tents, right? That means what do you need to get? The perimeter of this polygon, right? So we're going to do the same thing as we did in our previous example. How can you use what you know about finding distances from last lesson to find the perimeter of the building? You find the distance between 2 points. That could be one side, right? So first step, you need to mark the points. What are the coordinates of these points? Point A will be -4, 6. Point B will be 2, 6. Point C, 2, 1. Point D, -4, 1. Okay, these are the coordinate points. And now figure out the distances. A and D would be on the same quadrant. So they have the same x values. Their vertical distance would be their distance between them, right? So you add the absolute values of their y values. So 6, wait, you subtract because they're on the same quadrant. So 6 minus 1 would be 5. So that's 5 units. Let's check. 1, 2, 3, 4, 5. Yes, that is correct. 5 units. What about the horizontal distance between C and D? Okay. They're in different quadrants, so you need to add the distance between D to 0 and the distance between C to 0, right? So since their y values are the same, you're gonna use your x values to figure out the horizontal distance. Absolute value -4 is the distance between D to 0, and absolute value 2 would be the distance between C to 0, and you add them because they're in different quadrants. So 4 plus 2 would be 6. Let's check. 1, 2, 3, 4, 5, 6 units. That is correct. Okay. The opposite sides would have the same distance. So that's also 5. This is also 6. How much rope does she need to go around this building? 1 block is 1 meter, right? So 6 units means that's 6 meters. 5 units means that's 5 meters. 6 plus 5 plus 6 plus 5 should be your perimeter of this polygon in meters. So 6 plus 6, 12 plus 5 plus 5, 10, 22. Your perimeter should be 22 meters. Okay, so that's how much rope she needs. Let's try the try question. Make sure you come back for answers when you are done and you know how to solve this by yourself. Okay. The archaeologist later decides to extend the roped off area so that the new perimeter goes from A to B, to the food tent, to the working tent, and then back to A. How much rope does she need now? Right? So perimeter goes from A to B. A to B, and then to the working tent. So let me use a different color to indicate that this is a new problem. So A to B is still the same. That's going to be 6 meters. We already figured that out. But then she's going to extend this to B to the food tent, and then food tent to working tent, and then working tent to A. So we need to figure out the new vertical distance because your horizontal distance stays the same, but your vertical distance will be different, right? So you can either plus 1, 2, 3 units from 5, or you can also prove it by finding the coordinate of food tent, 2, -2, finding the new distance using algebra, right? 6 plus absolute value of -2 because they're in different quadrants, which is 8, right? So total would be 8 meters. So what's your new perimeter? 8 plus 6 plus 8 plus 6, right? Total 28. So let's fill in some blanks. Foot 10 to working 10. Absolute value 2 plus absolute value -4. 2 plus 4, 6 meters. Working 10 to 8. -2, absolute value -2 plus absolute value 6 is equal to 2 plus 6 equals 8 meters. So A to B is 6 meters. We already knew that. B to foot 10. Different points. That's still going to be the same, right? 8 meters, vertical distance, 8 meters. So archaeologist needs perimeter total 28 meters to rope. So how could you use the formula for the perimeter of a rectangle to find the perimeter of the larger rectangle using 2 of the distances? Okay, which formula? You're going to use the formula of what? The perimeter, right? How do you find, what was the perimeter formula that you used? 2 times the length plus 2 times the width, or length plus width plus width, okay? They're the same thing, okay? So show your work. You can plug in the specific values. Perimeter should be 2 times 6 plus 2 times 8 for the try question, right? So 12 plus 16 should equal to 28 meters. That's your work, and that's how you explain how you got it using the perimeter equation. Let's look at example 2 in page 107. Find the perimeter of an irregular polygon. A rancher maps the coordinates for a holding pen for his cows. How much fencing does the rancher need to enclose the cow's holding pen? So in this graph, you see a cow over here, and the ranch is going to go around, right? The fencing is going to be all these red lines. So first, you're going to find the side lengths. This is not a rectangle. It's maybe 2 rectangles together, or 6 sides. So that's going to be a type of hexagon, right? So we're going to look at these points and figure out the distances for all the different sides and just add them in order to get the total perimeter of this polygon. Okay, so using your knowledge to figure out the distances between 2 points, you figure out the distance between 2 points for every single line. Okay. So LM, NQ, QP, they're all going to be horizontal distance. So you use your X values because they're different, right? And all the other sides are vertical distances. Right, NO and QP or PQ. Okay, these are horizontal distances. And these are vertical distances. Okay, you can count the units, but you should also be able to use distance equations. Okay, if you add all of them, you should get 81 yards of fencing. Let's do try question number 2 together. You have a different formula, different polygon now. We want to put a fence around this horse, right? So how many yards do we need for the fence? Because it's 2 yards, right? 2 yards. Every unit is equal to 2 yards, right? So you need to keep that in mind. And this is the same, right? So that's going to be actually 2, 4, 6, 8, 9.5. Wait, 9 plus 1. Wait, 2, 4, 6, 8, 10 plus 1, 11 units. But you need to be able to use the coordinate points in order to figure out your distance, right? So figure out the distances between each points. Let's start with A and B, A to B, okay? We got 4.5 and 15. Okay, because they're on the same quadrant, you subtract their absolute values. So 15 minus 4.5 should be 10.5, right? B to C, that's a vertical distance. You use, let me draw a different. You use 14 and 8, they're in the same quadrant. So you subtract the absolute values of them. 14 minus 8 is going to be 6, right? 6 yards. Yeah. And what about C to D? Have 10 and 15. Subtract them, 5 yards. Okay. And then D to E, 8 and 3. Subtract their absolute values. 8 minus 3, 5 yards. Same. EF is also going to be 5 yards. And FG, they're on different quadrants, right? So you add the absolute values. 3 plus 2.25, 5.25 yards. Okay. What about H and G? H to G. They're in the same quadrant. So 15 minus 4.5, which is 10.5, same as A to B. And then lastly, H to A, back to point A. You use negative 2.25 and 14, and they're in different quadrants, so you add the absolute values of those two numbers, and you get 16.25. So you add all these numbers. 10.5 plus 6 plus 5 plus 5 plus 5. Okay, I'm going to use different colors to match our 10.5 plus 6 yards plus 5 plus 5 plus 5 plus 5.25 plus 10.5 plus 16.25. What is that equal to? 63.5 yards of fencing. So let's plug that answer in there, 63.5 yards. Right? Okay, example 3, apply distance to geometry. How can we apply distance to geometry? Let's look at this diagram. Our triangle ABC and triangle BCD isosceles. What does isosceles mean? They have 2 of the same length sides, right? And your base is the only side that is different, okay? So find the length of green sides of each triangle to figure out if they are equal to each other, okay? Length of side AC is going to be 6 units. Length of side DC is 6 units. Length of side BC is 6 units. So are the sides, or do we have 2 sides that are equal length? Yes, ABC is an isosceles. BCD is also isosceles. Okay, so the sides are the same length, so the triangles are isosceles. Try it. Queen says that quadrilateral ADEF is a square. Is he correct? Let's look at ADEF. In order to be a square, what do you know about squares? The sides are equal. So we need to figure out if the sides are equal. We already know the length of AC and CD. So if we add them up, that's going to be the total length of AD, which is 12, right? Let's look at DE. Is DE 12? If it is, then it's a square. If it's different, it's not a square. Okay. D, the coordinates of D should be 7, 2. Coordinate of E should be 7, -8. So let's look at your vertical distance. They're in different quadrants. So the distance, that's the value of the points should be added. So 8 plus 2 should be 10. 10 is not equal to 12. So no, it is not a square. Let's write that in full sentences. Quadrilateral ADEF is not a square because all 4 sides are not the same length. Okay, quadrilateral is any polygon with 4 sides. So let's summarize our lesson. What did we learn today? You can represent polygons on the coordinate plane and solve problems by using absolute value to find side lengths. Okay. You can add or subtract. So when do you add absolute values to find the side lengths, and when do you subtract? You add if the vertices are in different quadrants, and subtract if they are in the same quadrant. Okay. And how could you use the formula for the perimeter of a rectangle to find the perimeter of rectangle ABCD over here? You substitute 5 for L and 2 for W in the formula of your perimeter. 2 times length, 2 times plus 2 times width. Okay, so this was lesson 2-6, representing polygons on the coordinate plane. Thanks, guys. Bye. I'll see you in the next lesson.